If you care about real history that still matters today, subscribe to History Monuments now, because the survival of medieval houses is not an accident, not luck, and not magic. Across Europe, timber-framed homes from the 12th, 13th and 14th centuries are still standing, still inhabited, and still structurally sound. Meanwhile, modern houses built with treated lumber often suffer rot in less than 50 years. The difference lies in one overlooked principle medieval builders understood deeply. Rot is not defeated by chemicals, but by controlling moisture, airflow and wood behaviour from the moment a tree is cut. What follows is the exact anti-rot logic that allowed medieval homes to outlive empires. Why, you might wonder, did medieval builders treat rot as a design problem rather than, say, a material flaw? Well, medieval craftsmen did not view wood rot as something to be patched later. Instead, they treated it as a predictable biological process that could be prevented through structure orientation and preparation. They understood, quite astutely, that fungi require moisture, oxygen, and accessible nutrients. Remove even just one of these consistently, and honestly, decay slows to a crawl. Their buildings were designed to deny all three at once. This mindset alone, really, separates medieval longevity from modern failure. These days, rot is often addressed after construction. In the medieval world, rot prevention began before the first beam was raised. How timber selection quietly determined which houses would survive centuries. Medieval builders selected timber with extraordinary care. Oak was preferred not only for its strength, but for its dense heartwood, rich in tannins that naturally resist fungal growth. Trees were often sourced from old-growth forests, where slow growth produced tighter grain and fewer internal air spaces. Equally important was what they rejected. Sapwood, the outer living layer of a tree, was avoided whenever possible because it holds sugars that fungi feed on. Many medieval beams consist almost entirely of heartwood. This single choice dramatically reduced decay potential before construction even began. Why the season of cutting mattered more than modern preservatives. Timber was cut in winter, when SAP was lowest and moisture content naturally reduced. This deprived fungi of immediate nutrients and minimized internal cracking during drying. Trees cut in summer, when they're heavy with sap, well, they rot faster no matter how they are treated later. For modern application, this principle still holds, you know. Cutting or purchasing timber harvested during dormancy results in wood that dries more evenly and honestly resists decay longer without chemical intervention. It's fascinating how medieval drying methods prevented hidden internal rot. One of the most critical anti-rot tricks was actually simple separation. Timber frames were rarely placed directly into soil, which made a world of difference. Stone plinths, brick footings, or raised sills lifted wood above ground moisture. This prevented constant wicking of water into structural beams. How wall construction allowed buildings to dry instead of trapping moisture. Medieval wattle and daub walls were breathable. Lime plaster absorbed moisture during wet periods and released it during dry ones. Why roof design mattered more than wood treatment? Medieval roofs were steep for a reason. Water was shed quickly, minimizing saturation. Wide overhangs protected walls from driving rain. Eaves directed water away from timber joints, the most vulnerable points in any structure. So, how did medieval joinery reduce rot without the use of sealants? Well, mortise and tenon joints were cleverly cut to shed water naturally, you see. Peg joints, on the other hand, allowed just enough movement to prevent cracking. Now, why did medieval houses tend to age gracefully instead of failing all at once? When rot did begin, it would progress quite slowly. Breathable materials meant that any damage remained both visible and localized, making it much easier to address. So, how can we apply these medieval anti-rot principles today? First, choose dense, heartwood-rich timber. Make sure to harvest or buy wood that was cut during dormancy. Dry it slowly with plenty of airflow. Always raise wood above ground contact. And, of course, designed for drainage, airflow and breathability. Remember, treat moisture as the enemy, not time. These steps are simple, but together they really do replicate the logic that allowed medieval houses to stand for centuries. If this deep dive helped reveal why medieval builders consistently outperformed modern construction, well, do subscribe to History Monuments, share this episode with fellow history and survival enthusiasts, and help keep practical historical knowledge alive for the future.